When you hear the names Karl Marx and Friedrich Engels, you probably have a very specific set of images pop into your head.
Right. I mean, you definitely think of economics.
Yeah, economics, 19th century political revolutions, those massive tomes on capital and labor movements.
Factory conditions, things like that.
Exactly. But what you probably do not think of is like a passionate, borderline obsessive defense of global forests.
No, definitely not.
You don't think of soil chemistry or the microscopic division of cells or the laws of thermodynamics.
Yeah, it is definitely not the standard historical narrative most of us are taught in school. We tend to, pigeonhole historical figures into very narrow disciplines.
Right, like they only did one thing. But today, we are looking at a completely hidden side of history. So welcome to the deep dive.
Glad to be here.
We are exploring a massive intersection of ideas today. We're looking at the natural sciences, human interaction with nature, and some of the very first, pioneering ecological critiques ever put to paper.
And it's wild because we are looking at this through the lens of Marx and Engels.
Right. Who, as we are about to see, were essentially 19th century science nerds. I mean, they recognized the profound long-term environmental cost of industrialization decades before the environmental movement even existed.
Oh, the sheer volume of their scientific reading is genuinely staggering when you actually dig into it.
It really is. So for this deep dive, we are pulling from a massive stack of sources drawn from the Marx and Engels collected works.
Often abbreviated as the MECW, just so you know.
Right, the MECW. And this stack includes their personal correspondence, their philosophical notebooks, dense economic manuscripts like Capital, and Engels' unfinished but just incredibly detailed manuscript called The Dialectics of Nature.
Which is just a fascinating read.
It is, and our mission today is to decode this huge stack of sources. We want to extract the most fascinating insights into how these thinkers viewed the dynamic, ever-changing laws of nature.
And maybe more importantly, how they use those natural laws to pioneer a critique of how economic systems exploit the natural world.
Exactly. But before we get into the heavy science and the ecological theory, we do need to pause for a very important impartiality disclaimer.
Yeah, that is a very necessary step, given the sources we are working with today.
Yeah, because these texts contain politically charged revolutionary theories and heavy critiques of capitalism. So we need to make it explicitly clear that we, your hosts, are absolutely not taking any sides.
Right, not at all.
Whether you lean left, right, or center, our goal here is not to endorse the viewpoints found in these historical texts. We are not here to say their critique is the absolute undeniable truth.
We are just here to impartially report on the factual content provided in the sources.
Exactly, to help you, the listener, understand what these original ideas actually were and why they were arguing them. We are just the messengers here, decoding the historical material.
And honestly, regardless of your political or economic background, the material itself is objectively fascinating to decode. I mean, it offers a window into how people in the 19th century were trying to make sense of a rapidly changing world.
Okay, let's unpack this. To really understand how these thinkers viewed humanity's role in nature, we first have to understand how they viewed nature itself.
Right, we have to set the stage.
Yeah. We are talking about the mid-19th century, which is a time when the scientific world was undergoing an absolute revolution.
Oh, it was a paradigm shift of massive proportions.
Like total upheaval.
Yeah. I mean, to put this in perspective, prior to this period, the dominant scientific and philosophical view was what Engels called metaphysical.
Metaphysical. Now, in this specific context, metaphysical does not mean mystical or spiritual, right? Like, we aren't talking about reading crystals.
Right, no crystals. In the terminology of these texts, metaphysical means viewing nature as rigid, fixed, and totally unchanging.
Oh, okay. So you can almost picture it like a museum exhibit or like a clockwork machine.
Actually, a giant clockwork machine is the perfect analogy.
Right.
The old metaphysical view, which really dominated the 17th and 18th centuries, held that the universe was a stable, perpetually recurring circle.
Like a loop.
Exactly. God, or some prime mover, wound up the clock, and it just ticks away. Mountains were always mountains, valleys were always valleys.
The planets just moved in their orbits in exactly the same way since the dawn of time.
Right. And crucially, this applied to biology, too.
Highly crucially, I'd imagine.
Yeah. Under this rigid view, species of plants and animals were created once, in their final, perfect form.
So a horse was just always a horse.
A horse was a horse, a pine tree was a pine tree, and they just continually reproduced identical copies of themselves in this eternal, unchanging loop.
Wow. So there was no concept of real fundamental development over time.
Not at all.
So the universe is just this giant machine ticking away in space, but it never actually develops or evolves in time. It just spins its wheels.
That was the consensus. But by the mid-19th century, that Rigid Museum exhibit was being violently smashed to pieces by actual on-the-ground scientific data.
Which they must have loved.
Oh, they were obsessed with it. The texts highlight that Engels identified 3 great discoveries in natural science that completely shattered this static view of the universe.
The 3 great discoveries.
Right. And these discoveries proved that nature doesn't operate metaphysically. It operates dialectically.
Dialectically.
Yeah.
Okay, that is a heavy academic word that we are going to use a lot today. But before we define the philosophy, let's look at the actual science that forced the issue. What were these 3 great discoveries that blew up the clockwork universe?
Okay, so the first of the 3 was the cell theory.
The cell theory.
Yeah, this was developed by scientists like Matthias Schleiden and Theodor Schwann in the late 1830s.
Okay.
Before this, if you looked at a plant and a human, you saw 2 completely alien categories of existence. They had nothing to do with each other.
Right, a tree and a person. Totally different thing.
Exactly. But with the advancement of the microscope, Schleiden and Schwann proved that all complex organisms,
Like
everything, whether it's an oak tree, a dog, or a human being, they all grow and differentiate from a single fundamental building block, the cell.
Which is completely mind-blowing if you try to put yourself in a 19th century perspective.
It changes everything.
Right, you aren't just a static human that was dropped onto the earth fully formed. You are a wildly complex architecture built out of the exact same microscopic Lego bricks as, like, a blade of grass.
The implications were staggering for these guys. It showed that life is not a set of fixed categories, but a process.
A process.
Yeah, it is a process of continual division, growth, and transformation from a microscopic starting point. A cell divides, it differentiates, it becomes bone or muscle or a leaf.
Wow. So the rigid metaphysical boundaries between different types of biological life started to blur.
Because they all shared this universal origin point.
It bridges the gap between the plant kingdom and the animal kingdom. Okay,
Yeah.
so that's the first one, the cell theory. What was the second great discovery?
The second was the transformation of energy.
Okay, physics.
Yeah, established by physicists like Julius Robert Mayer, James Prescott Joule, and William Grove.
And before this, what did they think?
Before this, scientists believed that the forces of nature, like mechanical force, heat, light, electricity, chemical force,
Yeah.
they thought they were completely isolated, separate phenomena.
Oh, they thought of them as different fluids or distinct substances,
Yeah.
right? Like heat was a separate thing you poured into an object.
Exactly. They called it caloric. But Joule and others proved through meticulous experiments that these are actually not isolated at all.
They aren't.
No, they are all just different forms of a single universal motion.
Okay, walk us through how they actually proved that. Because it's one thing to say everything is connected. It's another to prove it in a lab in the 1840s.
Right. So take Joule's famous paddle wheel experiment.
A paddle wheel. Okay, picture this.
He set up a system where a falling weight was attached to a string, and that string spun a paddle wheel inside a sealed, insulated barrel of water.
Like a little water wheel inside a barrel.
Exactly. Now, as the weight fell, which is pure mechanical force, gravity pulling a mass,
Yeah.
it spun the paddles. The paddles created friction in the water. And Joule measured the temperature of the water with incredibly precise thermometers.
And what did he find?
He found that the mechanical force of the falling weight precisely correlated to a rise in the temperature of the water. Mechanical motion literally transformed into heat.
Oh, wow. So they pass into one another. You apply mechanical friction, you get heat.
Yes.
And if you apply heat to certain materials, you can produce light. Chemical reactions in a battery produce electricity, and you can use that electricity to trigger a different chemical reaction.
It proved the law of the conservation of energy.
Right.
Energy is never created out of nothing, and it is never destroyed into nothing. It merely constantly, endlessly transforms from one state to another.
So the universe is not a collection of isolated forces. It is a single, interconnected web of moving energy.
Exactly.
Okay, so we have the cells connecting all biology and the transformation of energy connecting all physics. And then comes the big one, the third discovery, the one that really upset the apple cart.
Oh, yeah. The heaviest blow to the static metaphysical view of nature. Charles Darwin's theory of evolution.
Now, the sources show that Marx and Engels were incredibly excited when Darwin published On the Origin of Species in 1859.
Oh, they were thrilled.
I mean, they were reading it almost immediately and writing letters back and forth to each other about how this completely validated their worldview.
Darwin provided the ultimate proof that nature has a history in time. He proved that all organic beings, including humans, are not fixed eternal categories.
We aren't clockwork.
Right. We are the products of millions of years of continuous, gradual evolution, driven by natural selection and adaptation to changing environments.
What's fascinating here is how Engels synthesizes these three discoveries. He isn't just looking at them as isolated fun facts.
No, he's building a system.
For him, the cell theory, the transformation of energy, and Darwinian evolution all proved a central philosophical point.
That the universe operates according to dialectics.
And this is where we need to define that term. Dialectics, as defined in these texts, is essentially the science of universal interconnection.
It is the logic of motion and change.
It argues that you cannot understand any single thing in the universe in isolation.
No, you really can't. You can only understand it by looking at its relationships, its history, how it came to be, and what it is in the process of becoming.
And the sources lay out some core laws of this dialectical movement, right? Like the unity of opposites.
Yes, the unity of opposites.
That sounds like a contradiction. How can opposites be unified?
I know, it sounds incredibly abstract, but the texts use a deeply relatable biological example. The human body.
Okay.
Think about your own body as you're sitting here listening to this.
Okay, I'm picturing my own body.
According to rigid metaphysical thinking, you are simply alive. Life is one category, death is another category, and they don't mix until the very end.
Right, you're alive until you're dead.
But according to dialectical thinking and modern biology, frankly, every organic being is at every single moment both the same and not the same. You are both living and dying simultaneously.
Because at a cellular level, things are constantly happening.
Yeah.
Like I am the same person who started talking 20 minutes ago, but physically, I am not the exact same matter.
Not at all. Your body is constantly assimilating new matter from the air you breathe and the food you ate, and it is simultaneously discarding old, dead matter. Inside your stomach lining, inside your blood, cells are dying and being reborn every single second.
Wow.
Over a period of several years, the actual physical matter that makes up your body is almost completely renewed. So you are always yourself, you have a continuous identity, and yet simultaneously, you are something other than yourself.
I really love that concept. Life and death aren't just two separate events that happen at the beginning and end of your timeline on a tombstone. They are opposites that are unified, constantly interacting inside you right now, continuously, to keep you alive. That is a dialectical reality.
And Engels takes this concept of fluid boundaries and applies it to the scientific disciplines themselves.
How so?
Well, the texts dive deep into the transition of the sciences to show this universal interconnectedness. Engels notes how one branch of science inevitably, naturally bleeds into the next. There are no hard borders.
Okay, walk us through that chain. How does it connect?
Let's start with mechanics, the study of the motion of masses.
Like big objects.
Yeah. If you have mechanical motion, like two massive rocks grinding against each other or a meteor hitting the Earth, that physical impact creates friction.
Right.
Friction generates heat. But what is heat? Heat is the motion of molecules. So mechanics naturally, inevitably leads into physics.
Okay, so the motion of big masses becomes the motion of molecules.
Yeah.
And physics leads to chemistry.
Exactly. If you apply enough heat or electrical energy to a substance, which is physics, you cross a threshold where the molecular motion becomes so intense that it causes a chemical change.
Oh, the atomic bonds break.
Right. The atoms rearrange into entirely new substances. The physics of heat transforms into the chemistry of atomic bonding. And chemistry ultimately leads to biology.
Which Engels was heavily reading up on.
He was fascinated by the latest research into protein and protoplasm. He saw that organic life was not some magical spark injected from outside the universe, but the result of incredibly complex chemical processes.
It is all one continuous evolving chain of matter in motion.
Exactly.
Which brings us to another major law of dialectics they talk about, which is the transformation of quantity into quality.
Yes, this is a big one.
And the sources have this incredible historical example using Dmitry Mendeleev and the periodic table of elements.
This is one of the most brilliant scientific examples highlighted in the text, and it perfectly illustrates the concept.
Okay, break it down for us.
To understand Mendeleev's breakthrough, we have to look at how he approached the elements. He took all the known chemical elements and arranged them according to their atomic weights.
Their weight.
Right. Now, atomic weight is a purely quantitative measure. It is just a number. It's an amount of mass. You are just adding more protons and neutrons to a nucleus.
It's just a head count of the stuff inside the atom. It doesn't tell you how the atom actually behaves.
Right. But Mendeleev noticed something extraordinary. He wrote the elements on cards, almost like playing solitaire, and arranged them by this increasing quantity of atomic weight.
And what did he see?
He saw that as you increase the quantity, the qualitative chemical properties of the elements don't just change randomly.
They don't.
No, they change periodically. They repeat in distinct patterns.
Meaning, by simply adding more mass, more quantity, you cross a threshold and suddenly get an entirely different quality.
Yes.
You add one more proton to a stable inert gas, and suddenly you have a highly reactive, volatile metal. The quantity physically transforms the quality of the substance.
And Mendeleev was so confident in this underlying dialectical law that he did something incredibly bold.
What did he do?
When he laid out his periodic table, he saw gaps. The pattern dictated that an element should be there, but no such element had ever been discovered by science.
So what, he just left them blank?
A metaphysical thinker might have said, well, the pattern is broken, the universe is chaotic, but Mendeleev didn't shrug. He predicted that these unknown elements must exist to fill those gaps.
The sources highlight the specific prediction of what Mendeleev called Ecological.
Right.
He literally wrote down the quantitative properties of an element that nobody had ever seen. He predicted its atomic weight, its specific volume, how it would react with oxygen, all based purely on this law of quantity and quality.
And what happens?
A few years later, in 1875, a French chemist actually discovers it in a zinc ore. We now call it gallium.
And its properties matched Mendeleev's predictions almost perfectly. The atomic weight, the density, the melting point.
That is wild.
Engels points out that Mendeleev pulled off this incredible scientific feat, predicting the future of chemistry, by unconsciously applying the Hegelian dialectical law of quantity transforming into quality.
Okay, wait. Let me jump in and push back here for a second.
Sir, go for it.
This sounds a little convenient for Engels. If science was already making all these massive discoveries entirely on its own, like Mendeleev with the periodic table, Darwin with evolution, Joule with energy,
Yeah.
why did Engels feel it was so important to slap this philosophical label of dialectics on it? Isn't he just sitting in an armchair watching scientists do the hard work in the lab and retroactively claiming their science for his own philosophy? Like, oh yeah, Mendeleev, he was doing my philosophy all along. He just didn't know it.
What's fascinating here is that that is a very common and very fair critique, and it is a question the texts themselves actually anticipate and address.
Oh, they do.
Yeah. Engels wasn't trying to force a preconceived philosophy onto nature from the outside. He explicitly states in the Dialectics of Nature that you cannot build the laws of dialectics into nature. You have to discover them in it.
Okay, so he's saying his argument was that nature inherently proves dialectics, whether the scientists realize it or not.
Essentially, yes, the facts force them into it, but Engels issues a severe warning, and this is why he felt the philosophy was necessary.
Why?
He argues that scientists who make these groundbreaking discoveries but still mentally cling to the old, rigid, metaphysical categories end up helpless to explain their own modern facts.
They get cognitive dissonance.
Precisely. Well, excuse me, let me rephrase that. They encounter a massive intellectual roadblock. If you discover evolution, which proves species fluidly change, but you still insist on categorizing the world into rigid, unchanging boxes, the endless confusion of modern theoretical science will overwhelm you.
You will have a mismatch between your data and your worldview.
Engels argued that dialectical thinking is the only framework that can actually keep up with the constant, interconnected transformations that science was uncovering.
Think about how often you see this today. You can see it in how we talk about modern issues. We constantly try to force a deeply complex, fluid world into rigid, unchanging binary categories.
We really do.
We want things to be strictly nature or strictly nurture, good or bad, success or failure. The sources are arguing that viewing the universe as an endlessly transforming, interconnected web of relationships isn't just scientifically accurate, it's an incredibly liberating way to think.
It really is. It frees you from rigid dogma.
Right.
And grasping that interconnectedness is the vital foundation for everything that follows in these texts.
Because if the universe is an ever-evolving, interconnected web of matter and energy, the next logical question, the question that bridges the natural sciences to economics, is where do human beings fit into that web? Right. And that naturally leads us to explore this incredibly poetic but deeply analytical concept found in the sources. The idea of the inorganic body. We've established the web of nature. How do humans plug into it?
To answer this, we look closely at Karl Marx's economic and philosophic manuscripts of 1844.
The 1844 manuscripts.
Yes. These are early, highly philosophical writings where Marx lays out the fundamental baseline relationship between the human species and the natural world.
Okay.
The central thesis he puts forward is that nature is man's inorganic body.
Man's inorganic body. That is such a striking, slightly counterintuitive phrase. Let's break that down because it's vital. My organic body is obvious. It's my flesh, my blood, my lungs, my stomach. What makes the forest or the river or the atmosphere my inorganic body?
The text explains it by looking at basic survival. Humans live on nature. You cannot breathe without the oxygen produced by the photosynthesis of plants. You cannot eat without the nutrients processed by the soil. You cannot build a shelter to survive the winter without wood or stone. Therefore, to say that human physical and spiritual life is linked to nature simply means that nature is linked to itself.
Because humans are fundamentally a part of nature.
Exactly that. We are not ethereal aliens dropped onto this planet from above. We are an expression of the planet itself evolved from it.
Wow.
The sources argue that humans can create absolutely nothing without the sensuous external world. Nature provides both the raw material for our labor, the wood we carve, the metal we forge, and the physical means of our daily subsistence.
So treating the external environment as something separate from us is a biological illusion. The atmosphere is literally an external lung.
Yeah.
The rivers are our external circulatory systems. The soil is our external digestive tract. Without them, the internal organic body dies in a matter of days or minutes.
That is a brilliant way to visualize it. The internal and external are one continuous biological system.
But this raises a profound question, doesn't it? If this connection is so natural, so vital, and so undeniable, why do we, as modern humans, feel so utterly disconnected from it?
It's a great question.
Look, why do we view nature as something out there, a place we visit on the weekends, rather than our own body?
And this is where the texts introduce the critical concept of alienation or estrangement.
Alienation.
Alienation is a massive theme in these manuscripts. The texts argue that the historical development of private property, and specifically the capitalist division of labor, actively severs the conscious connection between humans and the natural conditions of their existence.
Okay, walk us through what that actually looks like on the ground.
Yeah.
How does an economic system sever a biological connection?
Let's contrast two different ways of living. Imagine a pre-industrial artisan or a subsistence farmer.
Okay, like a guy in the 1700s growing his own food or making chairs.
Exactly. They work directly with the soil or the wood. They see the cycle of the seasons. They own their tools and they own the food or the chair they produce. The connection to the sensuous external world is direct. Now contrast that with a worker in a 19th century textile factory in Manchester.
Okay, the factory worker. Total opposite.
Total opposite. The factory worker does not own the land where the cotton is grown. They do not own the massive steam-powered looms they operate. And crucially, they do not own the final fabric they spend 14 hours a day weaving.
They just get a wage.
Because the worker is stripped of ownership of both the means of production and the fruits of their labor, nature ceases to be their inorganic body in a harmonious sense. Instead, nature, in the form of the raw materials and the factory, becomes an alien object.
It becomes a hostile environment.
Yeah.
You aren't interacting with nature to fulfill your human needs. You are battling this alien machine just to get a wage so you don't starve.
Exactly.
The texts actually make this point that the more the worker produces, the more they become a servant to the object they created.
The wealth they build out of nature confronts them as an alien dominating power. The massive factory they helped build now dictates their sleeping schedule, their health, their entire life.
Wow.
They lose that direct, harmonious connection to the sensuous world. Labor is no longer a joyful or creative interaction with nature. It is a forced, mechanical action merely to survive.
But hold on, let me play devil's advocate here.
Go for it.
Didn't humans always have to struggle with nature to survive? I mean, even that pre-industrial farmer had to break his back plowing a field, or risk starvation if there was a drought. What makes human production so inherently different from animal production? Because animals struggle too.
That's true, they do.
The sources draw a very sharp line here between human consciousness and animal instinct, don't they?
They do, and it's a fascinating distinction that elevates humanity while keeping us rooted in biology. The texts explicitly compare human production to animal production. Now, animals absolutely produce things. Birds build incredibly complex nests. Beavers engineer massive dams. Bees construct perfectly hexagonal hives.
Right. If an alien looked at a beaver dam, they'd say, that's infrastructure.
But the texts note a crucial limitation. An animal only produces what it immediately needs for itself or its young. Its production is one-sided, instinctual, and entirely bound by immediate physical necessity.
So a beaver does not build a dam because it appreciates the architecture?
No, or because it wants to experiment with a new style of dam, or because it wants to trade the dam to another beaver for extra bark. It builds it because its biology dictates it must.
It has no choice in the matter.
Conversely, humans, according to the manuscripts, produce universally. We can produce even when we are completely free from immediate physical need.
Like art.
Once we have enough food to survive, we don't just stop. We produce art, philosophy, massive global infrastructure. We can, as the text says, produce according to the laws of beauty.
We shape the world consciously. And the sources point out that this interaction, this unique way humans alter nature, is actually the evolutionary basis of human intelligence. Engels argues in his essay on the role of labor in the transition from ape to man that our intelligence increased precisely in the measure that we learned to change nature.
By working on the world.
Right, by working on the world, by inventing tools, we developed our own brains and our own hands. We literally built ourselves by building our environment.
It's a beautiful thought.
Okay, I follow the logic.
But I have to bring up a major historical contradiction here. If nature is truly our inorganic body, and our conscious interaction with it is what makes us uniquely human, then treating nature purely as a dumping ground or a warehouse for raw materials is essentially like amputating our own limbs. It's suicidal.
It is.
But didn't the Industrial Revolution have to treat nature this way to advance society?
What do you mean by that? I mean, if we didn't ruthlessly extract coal, cut down massive forests to build ships and build these polluting factories, we wouldn't have modern medicine. We wouldn't have global communication, the internet, or the comfortable lives we have today. We would still be subject to local famines and plagues. Wasn't this instrumental, somewhat destructive phase historically necessary?
If we connect this to the bigger picture, that is the exact tension at the heart of Marx and Engels' historical view. If we look at how they frame the timeline of history, the answer is a nuanced yes, but with a massive catastrophic caveat.
Okay, what's the yes part?
The texts, particularly in the Communist Manifesto and in Capital, absolutely acknowledge that the Industrial Revolution and the capitalist period of history were necessary historical steps.
So they weren't romanticizing the Middle Ages? They weren't advocating for a return to living in huts?
Not at all. They openly marveled at the immense technological achievements of the era. They recognized that capitalism was required to develop human productive forces to a global level, to break down local isolation, and to create what they called the scientific domination of natural agencies.
It built the machinery capable of ending natural scarcity.
Right.
So they acknowledged the immense power of the system. But what is the caveat?
The caveat is that while the system built incredible technology, it brought a fatal systemic flaw. It is structurally forced by its very economic laws to treat nature purely as an object of utility.
Just a resource.
A resource for immediate profit, rather than as a complex, interconnected biological web that sustains all life. And if you run a system with that fundamental flaw long enough, the consequences are disastrous.
Which takes us right into the core of their ecological critique. If we treat our inorganic bodies strictly as a resource for immediate economic gain, what actually happens to the environment? We're moving from the philosophy to the dirt, the water, and the trees.
According to the texts, what happens is a slow-motion catastrophe. These writings pioneer a profound ecological critique of capitalism that feels startlingly modern.
It really does.
They argue that while capital's supreme role leads to this incredible scientific domination of nature, it does so blindly with disastrous side effects.
Because the entire system, regardless of the good intentions of any individual person within it, is driven by one overriding structural imperative: the immediate short-term accumulation of surplus value, or, in plain English, profit.
The system acts as if humanity rules over nature, to use Engels' exact phrase, like a conqueror. It views nature as a foreign territory to be plundered, rather than a body we are a part of.
And because the capitalist system demands constant, infinite expansion like If the economy stops growing, it faces a catastrophic crisis.
Right, it must consume resources at an ever-accelerating rate.
There was a phrase quoted in the text which Marx attributes to the ultimate battle cry of capital. Après moi le déluge.
After me, the flood.
After me, the flood. It is the absolute pinnacle of short-term thinking. I will extract my profit today, and if the world washes away tomorrow, well, I'll be dead. So it's someone else's problem.
The sources argue that because of this dynamic, capitalist production is incredibly squandering of material natural resources. And the mechanism behind this is fascinating.
How does it work?
The capitalist calculations only account for the intended social and economic effects of production.
Intended effects, what does that mean?
What is the intended effect? Producing the commodity, selling it, and pocketing the profit, they completely ignore and are in fact structurally incentivized to ignore the unintended natural effects.
Because in the strict accounting books of a 19th century factory owner, natural elements don't have a price tag.
No, they don't.
The natural fertility of the soil, the cleanliness of the air, the purity of the river water, these cost absolutely nothing to the capitalist. They are freebies from nature. So there is an inherent systemic drive to exhaust them to zero.
And the sources provide some incredibly vivid, scientifically detailed examples of this. Let's look at the Spanish planters in Cuba, which is a case study specifically highlighted in Engels' Dialectics of Nature.
Oh, this is a great example.
It perfectly illustrates the divide between intended economic success and unintended ecological ruin.
Let's dig into the mechanics of this. What did the planters do, and why did they do it?
Okay, so the Spanish planters in Cuba wanted to grow coffee. Coffee was a highly profitable cash crop in the global market. But coffee plants require incredibly nutrient-rich soil to yield a highly profitable harvest quickly.
Okay, so they need good soil fast.
Right. To get the best fertilizer instantly, the planters looked at the lush, ancient mountain forests of Cuba, and they just burned them down.
Slashing and burning the old-growth forest. Now, why does burning a forest help grow coffee? We have to explain the chemistry here that the texts were picking up on.
When you burn a forest, the massive amount of carbon, potassium, and calcium stored in the wood is reduced to ash. This ash, particularly the potash, creates a massive temporary spike in soil alkalinity and nutrient availability.
It is like giving the soil an energy drink.
Exactly. The planters planted their coffee trees in this freshly burned, highly energized soil, and the intended consequence was achieved. They got one generation of highly profitable coffee trees. They made an absolute fortune.
Massive intended economic success. They take their money to the Bank of Madrid. But what was the unintended consequence that they ignored?
They ignored the biological architecture of the forests they destroyed. What happens when you remove a forest canopy and the massive root systems?
The texts point out that they didn't care that the heavy tropical rains subsequently washed away the unprotected topsoil.
Because the roots of a forest act like rebar in concrete. They hold the soil matrix together. And the canopy of the leaves softens the physical impact of millions of gallons of tropical rain.
Right. When you remove both, the rain acts like a power washer.
Exactly. Without the roots to hold it, the topsoil, which took thousands of years of biological processes to build up, just washed down the mountainsides in a matter of a few rainy seasons, leaving behind only bare rock.
Wow.
They completely destroyed the physical foundation of the ecosystem for a single generation of profit. Après moi le déluge, quite literally, the soil washed away.
Another fascinating example the texts dive into is the economics of forestry. And this one really exposes the fundamental conflict between the biological clock of nature and the financial clock of capital.
Yes, the economic problem of trees. In Volume 2 of Capital, there is a deep dive into what is called the turnover time of capital.
Turnover time.
If you are an investor, you want your money back with profit as quickly as possible. If you plant a crop of wheat, you harvest it in 6 months. You get your return on investment quickly. But if you plant a forest for timber, what is the turnover time?
I mean, a pine tree might take 50 years to mature. An oak tree might take a century.
Exactly. Capitalism abhors waiting a century for a return on investment. The investor will be dead before the tree is cut.
Yeah, that math doesn't work for them.
Because the turnover time is so long, forestry, meaning the sustainable planting and cultivation of trees, is largely unattractive to private capitalist enterprise.
The biological cycle of the tree cannot be reconciled with the quarterly earnings report.
Therefore, the texts note that the advance of civilization and industry evinces itself in the energetic destruction of forests. A private timber company will gladly chop down a 500-year-old forest because nature already did the waiting for them. You know, the profit is immediate.
But the efforts made by private enterprise to preserve or replant them are described as infinitesimal, because replanting simply doesn't pay out fast enough to satisfy the demands of capital accumulation.
And we see this play out globally in the text. It wasn't just happening in Cuba or in European forests. The texts heavily condemn English colonial rule in India for a similar kind of massive ecological neglect driven by extraction.
The situation in India was devastating, and Marx wrote about it extensively. The sources detail how the English colonial system combined the worst, most oppressive aspects of Eastern despotism with modern, ruthless capitalist extraction.
It was a brutal combination.
To maximize their plunder of the country's wealth, the English colonialists completely neglected the vital, ancient public works, specifically the irrigation systems that Indian agriculture relied upon.
They extracted the cotton and the agricultural wealth, but refused to spend the money to maintain the environmental infrastructure, the canals, the reservoirs, that actually allowed the soil to produce the wealth in the first place.
Because maintenance eats into the immediate profit margin. As a result, massive swaths of Indian agriculture were driven to ruin, leading to horrific preventable famines.
It's just devastating.
Now, here's where it gets really interesting. As I was reading through these sections in Capital, I couldn't help but notice a direct, terrifying parallel. I want to see if I'm reading this right.
Okay, what is it?
It sounds like they are arguing that capitalism treats the soil, the earth, exactly the same way it treats a factory worker's physical body.
Oh, that is a very astute connection, and it is not accidental. It is explicitly drawn out in the texts. The system operates on the exact same logic for both the earth and the human being. Squeeze out the maximum immediate value, externalize the costs, and discard the ruined shell.
Let's break down how that works inside the factory. Just like the soil in Cuba was exhausted and left as bare rock, the worker in the 19th century factory was exhausted and discarded. And the texts use a specific economic term for this, the economy of constant capital. We need to explain what that means to understand the physical toll on the worker.
This is a crucial concept in Capital. Marx divides the capitalist's investment into two main categories: constant capital and variable capital.
Okay, variable and constant.
Variable capital is the money spent on wages. It buys human labor power. Constant capital is the money spent on everything else: the raw materials, the machinery, and the physical building itself.
So the cotton, the loom, and the brick factory building are constant capital.
Right. Now, in order to maximize profit, the capitalist is driven to economize, to ruthlessly cut costs on constant capital.
How do you save money on the factory building?
You cram as many machines and workers into as small a space as possible. You refuse to spend money on safety devices for the gears. And crucially, you refuse to spend money on proper ventilation, lighting, or sanitation.
Because putting in a ventilation system to clear out the cotton dust doesn't produce any extra cloth. It's a dead expense for the owner.
Exactly. Marx refers to this ruthless cost-cutting as the prodigious dissipation of the laborer's life and health.
Wow.
By saving money on ventilation, the capitalist is essentially treating the workers' lungs exactly like they treat the atmosphere, as a free dumping ground for industrial waste.
The cotton dust fills the workers' lungs, causing horrific respiratory diseases. The lack of space leads to workers being mangled by machines.
The capitalist views spending money on clean air or reasonable hours as a senseless waste, because it eats into the profit margin.
It's brutal.
The system relies on a constant current of quickly fading generations of workers, plucked to full maturity, used up physically by the time they are 30 or 40, and then replaced by the next generation of desperate workers. The economy of constant capital is achieved by squandering the variable capital, the human life.
Think about how often you see this exact dynamic playing out today. You look at the news, and you see a massive corporation prioritizing this quarter's earnings report over decades-long environmental sustainability, or lobbying against workplace safety regulations because it costs too much to implement.
The scale has become global, but the underlying logic is identical.
It is wildly fascinating and a bit sobering to see the mechanical roots of this behavior being meticulously diagnosed and documented over 150 years ago.
It shows that the ecological and social crises are not glitches in the system. They are features of how the system is designed to operate. And that brings us to a really critical juncture in the text, where the scientific worldview and the economic critique collide.
Yes, the misuse of science. Because Marx and Engels respected science so deeply, because they saw Darwin's theory of evolution as one of the great triumphs of human thought, they were incredibly critical when they saw science being misapplied to justify brutal social and economic conditions.
We mentioned Darwin earlier and his concept of the struggle for existence. In the natural world, Darwin observed that more organisms are born than can survive, leading to a literal biological struggle for limited resources.
Right.
But in the late 19th century, a philosophical and political trend emerged that we now call social Darwinism.
Ah, yes.
Theorists and apologists for the capitalist system began applying this biological struggle for existence directly to human history and human society.
They argued that the brutal inequality of capitalism, the fact that factory owners lived in mansions while workers starved in slums, wasn't a flaw in the economic system. They argued it was merely the natural law of the universe asserting itself.
Exactly.
Survival of the fittest applied to the stock market. If you were poor, it was because you were biologically less fit to survive.
And Engels was furious about this. He wrote extensively in his letters and in the Dialectics of Nature, warning against this. He argued that reducing the entirety of complex human development to a simple biological struggle for existence is a profound false equivalency. It is historically and scientifically inaccurate.
How does he break down that false equivalency? Because on the surface, if humans are animals, shouldn't animal laws apply to us?
He returns to the distinction we discussed earlier between how animals interact with nature and how humans interact with nature. In the animal kingdom, animals merely collect what nature provides.
Right, they collect.
If there is an overpopulation of rabbits and a drought limits the amount of grass, there's a literal, desperate struggle for existence because the resources are strictly finite. The rabbits cannot invent a new way to grow grass. Nature sets a hard limit.
But humans, as we established, produce. We don't just collect what's there.
Right.
We actively, consciously alter nature to artificially multiply our means of subsistence. Through the invention of agriculture, the plow, the steam engine, and industrial chemistry, we create vast surpluses. We shatter the natural limits.
Therefore, Engels argues, the struggle in human society isn't just a desperate scramble for pure biological survival. Because human society produces more than enough to physically survive, the struggle shifts.
What does it shift to?
It becomes a struggle for the means of development and enjoyment. It's a struggle over who gets to control, distribute, and benefit from the massive surplus that society produces.
And the sources point out a fascinating economic paradox that proves this. The crises we see in capitalist society are fundamentally entirely different from crises in the animal kingdom. An animal crisis is a crisis of scarcity, not enough food. But capitalist crises, like the massive economic crashes in the cotton and iron industries that Marx analyzed, are crises of overproduction.
This is perhaps one of the most counterintuitive but brilliant insights in their critique. Explain what a crisis of overproduction looks like.
Based on the texts, it's a situation where society isn't starving because there isn't enough wealth. People are starving because there is too much wealth.
It sounds absurd, doesn't it?
It does. The factories become so efficient that they produce more coats, more shoes, and more food than the market can absorb at a profit. Because the working class isn't paid enough to buy back the goods they produced, the goods sit in warehouses.
And what does the capitalist do when they can't sell the goods at a profit?
They shut down the factory. The workers are thrown out into the street. They have no wages, so they can't buy food. They freeze in the winter while warehouses down the street are literally overflowing with coats.
Yeah.
Sometimes, the texts note, the wealth is intentionally destroyed. Crops are burned. Milk is dumped in the river just to artificially restrict supply and keep prices up.
It is an artificial famine amidst a mountain of plenty. And Engels points out the profound absurdity of looking at a crisis of overproduction and calling it a natural struggle for existence.
Right? The food exists. The coats exist. The workers are barred from accessing them, not by biology, but by the economic laws of the market.
Furthermore, Engels pushes back on the biological side of social Darwinism. He argues that even if you look at nature itself, reducing everything to a bloody competitive struggle is highly one-sided. He leans heavily on the work of the agricultural chemist Justus von Liebig to show the harmony of nature.
Oh, Liebig. He is a fascinating figure in this context. He was a pioneer in organic chemistry, and Marx and Engels studied his work on soil fertility intensely.
Yes, they did.
Liebig demonstrated that nature is not just a battlefield. It is characterized by profound, necessary cooperation and metabolic exchange.
Walk us through the chemistry of that cooperation.
Take the interaction between the plant kingdom and the animal kingdom. It is a perfect dialectical unity. Plants, through photosynthesis, take in carbon dioxide and supply the oxygen and complex carbohydrates that animals need to survive.
Correct.
In return, animals inhale that oxygen, exhale the carbonic acid, the carbon dioxide the plants need, and animal waste provides the nitrogen and phosphorus manure that fertilizes the soil for the plants to grow.
It's a perfectly balanced cyclical metabolism. To look at that intricate, billions of years old web of cooperation and label the entirety of nature strictly as a struggle ignores the reality of how life actually sustains itself.
Okay, but this brings up a massive contradiction, and it's something I want to put to you.
Okay, what is it?
If human production is so massive that we transcend the animal struggle for existence, and if nature itself has all this built-in cooperation and balance, why did Marx and Engels argue that the working class in their time was still living in such brutal dog-eat-dog conditions? If it isn't natural, why is it happening?
This raises an important question, and the answer forms the conclusion of their entire critique. The texts conclude that these brutal conditions are entirely artificial. The capitalist system forces this competition. The structure of private property and wage labor isolates people, turning them into what the texts vividly describe as mutually repelling atoms.
Mutually repelling atoms.
Yeah.
Because you were forced to compete with the person next to you just to survive.
Exactly. The system pitches worker against worker in a desperate competition for limited jobs and wages. It pitches capitalist against capitalist in a ruthless competition for market share and cheaper resources.
So it mimics a vicious state of nature. But it is actually a human-made economic construct.
Yeah.
We built the cage, we locked ourselves inside it, we threw away the key, and then we pointed at the bars and claimed it was just the law of the jungle.
That is the perfect summary. The struggle for existence in human society under capitalism is not a law of biology. It is a law of the specific economic system we have created.
Wow.
And the overarching point of all their political writing is that because it is a human creation, it is not eternal. It can be changed by human action. We are not doomed by our biology to destroy the planet or exploit each other. We are currently constrained by our economic architecture.
So what does this all mean? We have covered an absolutely massive amount of ground today. Let's try to pull all these threads together.
Good idea.
We've looked at texts from Marx and Engels that reveal a worldview where absolutely everything is interconnected. We started with the microscopic division of cells, moved to the universal laws of thermodynamics, looked at the macroevolution of species, and followed that all the way up to how human economic systems interact with the soil of the Earth.
It is a profoundly holistic view of the universe. They were looking at the Earth as a single, complex, metabolic system long before the term ecology was even in popular use. They understood that you cannot sever the economy from the environment.
And the core takeaway for us pulling from all these sources is this: treating humanity as conquerors of nature, standing outside of it and treating it purely as a free warehouse to be plundered for short-term profit, is a fundamentally flawed biological premise.
It is.
It inevitably leads to the reckless destruction of the very inorganic body we rely on to survive. Whether it's washing away the topsoil in Cuba for a quick coffee harvest, destroying ancient forests because they don't grow fast enough for investors, or exhausting the lungs of a worker in a textile mill, the logic of infinite extraction eventually hits a biological wall.
The Earth has limits. The human body has limits. Capital does not recognize those limits. And by taking the time to understand these historical texts, you are much better equipped to see the deep philosophical and economic roots of the ecological debates we're having today.
Absolutely.
The arguments about climate change, resource depletion, and labor rights haven't changed in their fundamental structure. The scale has just gotten larger. We are now seeing the planetary consequences of the exact dynamics they described 150 years ago.
Which leaves us with a final thought to mull over, circling back to where we began. We've seen how the 19th century worldview shifted from a static, unchanging universe to one of constant evolution and interconnectedness. If the sources are right, if a system requiring constant expansion and infinite economic growth will inevitably hit the hard physical limits of the natural world, we have to ask ourselves a very difficult question today.
Yeah.
Can any economic model that prioritizes endless accumulation ever truly be reconciled with the finite planet? Or are we, like those 19th century factory owners, just closing our eyes, taking the profit, and waiting for the flood?